I welcome every one of you to my last part in the study of nitric acid of class 10 of ICSE syllabus. In this part, we will be studying uses of nitric acid and tests for nitric acid and nitrates, and lastly we will study effect of heat on nitrates. This will conclude our chapter. Okay, let's start. Now, if we continue with the study, we see that nitric acid is used to its designs on copper and brassware because it acts as a solvent to a large number of metals except some noble metals. For noble metals, we can give specific examples of platinum and gold. We can use nitric acid to purify gold, and the reason is that as impurity we have copper, silver, zinc, lead, etc., and these are soluble in nitric acid, so we can use nitric acid to purify gold. We can use nitric acid as oxidant in rocket fuel. We can use nitric acid to prepare nitrogenous fertilizers, for example calcium nitrate, ammonium nitrate, nitro chalk, basic calcium nitrate. So these are the various nitrogen containing salts that can be used as a nitrogenous fertilizer, but they have some drawbacks also. We have new generation nitrogenous fertilizers like urea and other things. Now it is also used in the preparation of aqua regia to dissolve noble metals. We have studied it in our previous lecture. In industry, we can use it to prepare explosives like TNT, synthetic fibers like artificial silk, nylon, celluloid, plastic, photographic films, etc. And we can even use it to synthesize important compounds like nitrates of potassium, ammonium and silver. We can use it to prepare dyes, different drugs and perfumes. Okay, so with this we conclude the first part of uses of nitric acid, and then we hear how to identify nitric acid. This is really important from academic point of view. Nitric acid, when it is concentrated, gives up brown fumes as nitric acid decomposes in presence of heat to produce nitrogen dioxide. This nitrogen dioxide gas comes as brown fumes. Okay. Metal nitrates, other than potassium, sodium and ammonium nitrate. Only these three are the exceptions. We will study about these three in the next point. Let's continue for nitrates other than potassium, sodium and ammonium nitrates. When we heat those metallic nitrates, we get metallic oxide, nitrogen dioxide and oxygen. But what about the nitrates of potassium, sodium and ammonium? Yes, they can be identified if we add some acid other than nitric acid. We can add hydrochloric acid, we can add sulfuric acid to the nitrites, to any nitrate, and we can put some copper in it. So hydrochloric acid or nitric acid will react with those nitrates to form nitric acid, and that nitric acid will combine with copper to form copper nitrate, water and nitrogen dioxide, and this nitrogen dioxide will come out as a brown fumes. So we can understand it, we can identify it. Okay, so this is the reaction for copper with nitric acid. Now this can happen also when we have a mixture of sodium nitrate and sulfuric acid. You see, this mixture will produce nitric acid and then it will react with copper to give products. So we can identify by the brown fume of nitrogen dioxide that comes. Okay, next step, very authentic step to identify brown ring test is to identify nitric acid is the brown ring test. We can perform the brown ring test formation. It's a little tricky, but we should learn it so that we can perform it in our laboratories. Now in step 1, we prepare ferrous sulfate salt. Generally we take more salt in our laboratories as a source of ferrous sulfate. Then we dissolve it. On this we mix aqueous solution of nitric acid or some nitrates. Okay, after that, in the next step we will mix concentrated sulfuric acid by the side of this test tube. It will just trickle down slowly to the bottom, and this area will contain nitric acid, and this upper area will contain the aqueous solution of the salt along with freshly prepared ferrous sulfate solution. In this junction, we will see a brown ring. This brown ring clearly identifies nitric acid or a nitrate salt. You see, whenever you mix some acid, sulfuric acid to a nitrate salt, it will form nitric acid, and that nitric acid will react to form this brown ring. Now, this has a chemical reaction, and your book does not give the full reaction. Still, it is authentic. Here what happens is that we have ferrous sulfate, we have sulfuric acid, nitric acid, they form ferric sulfate, water and nitric oxide. Okay, this nitric oxide reacts with ferrous sulfate to form nitrosoferrous sulfate. Presently we know that this actually is not nitrosoferrous sulfate. We call it by a different name. I will write it for you so that you can understand. We call it as the compound is we should write it as Fe and then H2O5, and I don't have space, so here we will write NO, and we will close the third bracket, and then we will put SO4. So the name is penta-aquo nitrosyl ferrous sulfate. This is the name. I hope you will understand it. If you search in Google or in higher books, you will get this compound. This is the compound that gives the brown ring. Now, there are 3 points that is to be noted: that we need a freshly prepared ferrous sulfate solution, because on exposure to atmosphere, ferrous sulfate turns to ferric sulfate, and that doesn't give the reaction. The brown ring of nitrosoferrous sulfate is formed at the junction of the two liquids, and for this we have to pour sulfuric acid very slowly, and sulfuric acid being heavy will go down. Okay, if we disturb the test tube, the brown ring can decompose or vanish, or it may so happen that a whole of the solution will become brown. This also happens in experiment, as I have seen it in laboratories. Okay, now the last part consists of effects of heat on nitrates. This is very important. Okay, nitrate, we have sodium nitrate and potassium nitrate. When you heat the nitrates of sodium and potassium, you get the corresponding nitrite and oxygen. All other nitrates except those of silver and mercury will decompose to form their oxides and nitrogen dioxide and oxygen. What about silver and mercury? We'll study it a little later. Okay, here we have all other nitrates: calcium nitrate, zinc nitrate, lead nitrate, copper nitrate, and the products: oxide, calcium oxide, zinc oxide, lead oxide, copper oxide, cupric oxide specifically speaking. And their colors, you need to remember the colors. Calcium oxide is white, zinc oxide is white when cold and yellow when hot. Lead oxide is yellow solid, fuses with glass, and cupric oxide is black in color. Along with these oxides, we have nitrogen dioxide gas and oxygen gas. So this is the specific property of metal nitrates except silver and mercury. Now let's study silver and mercury. Silver and mercury being below metal activity series, they decompose to produce metallic silver and metallic mercury along with nitrogen dioxide and oxygen. This is similar with our other metal nitrates that we have seen a little ago. So we have the last one. The last one in this chapter says that ammonium nitrate, and if we heat ammonium nitrate, what happens is that we get nitrous oxide and water vapor. So from a solid crystalline substance we have two gases. The expansion in volume will be enormous and it will function as an explosive. With this we end this chapter, and thank you very much for being with me. We conclude here the study of nitric acid. All the best, my dear students.